Welcome to Economics Workshop. In our tutorial today, we'll be looking into derivative in Economics 2. Today's tutorial is the continuation of the previous one. Try to get the previous video on differentiation. So in this tutorial today, we'll be looking into chain rule, differentiation from first principle, implicit differentiation, higher order derivative. Chain rule. A chain rule is used when a function of function is involved, such that y is a function of u and u is a function of x. That is, y equals to what? F of u, and u equals to what? H of x, and y is equals to what? F of what? H of x. The derivative is derived by multiplying the derivative of the first function, that is y equals to f of u with respect to u, and the derivative of the second function, which is what? U equals to f of x with respect to x. That is, the y dx is given as the y du multiplied by the u dx. So given y equals to 2x raised to the power 3 plus 4x all raised to the power 5, find the y dx. So first thing we have to do is what? You let u equals to what? 2x raised to the power 3 plus 4s. That is the function neglecting the power. So I can also write that y equals to what? U raised to the power 5. So y equals to u raised to the power 5, we can find the y du. From here, the y du equals to what? 5 multiplied by u raised to the power 5 minus 1, which is what? 5u raised to the power 4. Since u equals to 2s raised to the power 3 plus 4x, du dx equals to what? 2, we are applying some rule here. 2 multiplied by 3x raised to the power 3 minus 1 plus 4, which equals to what? 6x raised to the power 2 plus 4. Now we are applying the chain rule. Chain rule, the y dx equals to what? The y du multiplied by the u dx. So the y dx equals to 5u raised to the power 4 multiplied by what? 6x raised to the power 2 plus 4. So we substitute the what we've gotten earlier into that chain rule. So since u equals to 2x raised to the power 3 plus 4x, then the y dx equals to what? 5 open bracket 2x raised to the power 3 plus 4x close bracket raised to the power 4 open bracket 6x raised to the power 2 plus 4 close bracket. So what we did here is what? Is to substitute what we got as the y du. So the y dx equals to what? 5 open bracket 6x raised to the power 2 plus 4 open bracket 2x raised to the power 3 plus 4x close bracket raised to the power 4. So the y dx, when we open the bracket, we have 30x raised to the power 2 plus 20 close bracket 2x raised to the power 3 plus 4x all raised to the power 4. We move on to differentiation from first principle. For this, we need the knowledge of binomial expansion. You can see on the right hand side there we have a triangle like that object that display different number. Those numbers represent coefficients. So whenever we are expanding a bracket that involves power of 2, 1 2 1 is the coefficient to use, y power 3 1 3 3 1 is the coefficient to use, power 4 1 4 6 4 1 are the coefficient to what to use whenever we are expanding. The following are the steps involved using first principle. Example: differentiate y equals to 2x raised to the power 2 using first principle. Solution: step 1, add changes of each variable in each term. That is y plus change in y. In our function we have y equals to 2x plus 2. So you add change in y to y, and you add what? Change in x to what? To x. So we have y plus change in y equals to what? 2 open bracket x plus change in x close bracket raised to power 2. Step 2, open the bracket using binomial expansion. So we have x plus change in x raised to power 2. We have to open that bracket. So what are the coefficients to use? We have 1 2 1 as our coefficient. So we have y plus change in y equals to what? 2 open bracket. We have 1 x raised to power 2 change in x raised to power 0. We are going to include our coefficient, our variables x and change in x. The powers of x will be decreasing while the powers of change in x will increase. So we have plus 2, which is the second coefficient, x raised to power 1. You can see the power of x decrease from 2 to 1, plus 2x raised to power 1 change in x raised to power 1. The power of change in x increase from 0 to 1, plus 1, which is the last coefficient, x raised to power 0 change in x raised to power 2. The power of x decrease from 1 to 0, while the power of change in x increase from 1 to 2. So we have that y plus change in y equals to 2 open bracket. When we simplify the bracket, we have x raised to power 2 plus 2x change in x plus change in x raised to power 2. We have y plus change in y equals to what? 2x raised to power 2 plus 4x change in x plus 2 change in x raised to power 2. We open the bracket. Step 3. Move y to the right hand side and substitute its value. So we have to move y to what? To the right hand side of the equation and substitute it what? Its value. The value for y is what? 2x raised to power 2, which is our function. So we have change in y equals to 2x raised to power 2 plus 4x change in x plus 2 change in x raised to power 2 minus y. Change in y equals to 2x raised to power 2 plus 4x change in x plus 2 change in x squared minus 2x raised to power 2. So 2x raised to power 2 subtract 2x raised to power 2. We have change in y equals to 4x change in x plus 2 change in x raised to power 2. So we factor out change in x in the right hand side of the equation. Therefore, we have change in y equals to what? Change in x open bracket 4x plus 2 change in x. Step 4, we have to find change in y divided by what? Change in x. So when we divide change in x by both sides, we have change in y divided by change in x equals to 4x plus 2 change in x. Since we still have change in x in the answer, we have to what? Limit change in x over change in y as what? Change in x approaches 0. What are we to do here? We are just to substitute the value of change in x with what? With 0. So we have the y dx equals to what? 4x plus 2 open bracket 0 close bracket. So the y dx equals to what? 4x. Implicit differentiation. An implicit function is a function in which the dependent and independent variable appears on the left of the equal sign, e.g. 2xy plus 7y raised to power 4 equals to 0, 5y raised to power 2 plus 2x raised to power 2 equals to 0. So when we have the dependent and the independent variable, that is x and y, on the left hand side of the equal to sign, we have what? An implicit differentiation. In this kind of function, you can't differentiate which one is the dependent or the independent or the dependent. Example: differentiate 3x raised to power 3 plus 8y raised to power 7 minus 50 equals to 0. Step 1. Multiply each term by d dx and differentiate with respect to s. So when we multiply each term by d dx, we have d dx open bracket 3x raised to power 3 close bracket plus d dx open bracket 8y raised to power 7 close bracket minus d dx 50 equals to d dx open bracket 0 close bracket. So we have to differentiate each term with respect to s. So when we differentiate 3x raised to power 3 with respect to s, we have what? 3 multiplied by 3x raised to power 3 minus 1 equal, which is what? 9x raised to power 2. When we differentiate our constant, we said the derivative of a constant equals what? 0, and the dx of 0 is also what? 0. So to differentiate 8y raised to power 7, we are going to make use of the generalized power rule. To differentiate that, we have d dx open bracket 8y raised to power 7 close bracket equals to 8 multiplied by 7 multiplied by what, y raised to power what, 7 minus 1 d dx y. That is, we are to differentiate the function itself, which is y. So when we multiply that, we have 56 y raised to power 6 dy dx. Don't forget d dx of y is same thing as the y dx, and that is the reason why we have 56 y raised to power 6 dy dx. Therefore 9x raised to power 2 plus 56y raised to power 6 dy dx plus 0 equals to 0. So we are adding all the derivative together into what, into the, we have 9x raised to power 2 plus 56y raised to power 6 dy dx minus 0 equals to what, 0. Step 2, solve for the y dx. So we have 56y raised to power 6 dy dx equals to minus 9x raised to power 2. dy dx equals to what, when we divide both sides by 56y raised to power 6, we have dy dx equals to minus 9x raised to power 2 divided by 56y raised to power 6. So this is how to differentiate an implicit function. Lastly, in this video we look into higher order derivative. Higher order derivative are found by successive application of the derivative rule. Example, given f of x equals to 2x raised to power 4 plus 3x raised to power 3 plus 5x raised to power 2. Taking the first derivative, we have f prime of x equals to what? 4x raised to power 3 plus 3x raised to power 2 plus 10x. Applying the derivative rule on the first derivative to get our second order derivative, we have f prime prime of x equals to what? 12x raised to power 2 plus 6x plus 10. Applying the derivative rule on the second order derivative, we have f prime prime of x equals to what? 24x plus 6, while f raised to power 4, f of 4x equals to what? 24. So these are to take higher order derivative. It is just, they are found by successive application of the derivative rule. We have come to the end of differentiation. Check the previous tutorial with this and learn how to differentiate different economics function. Thank you for watching.